Question 4 is all about the normal distribution, and we are investigating the distribution of time in hours that a phone will work for before it needs charging. Now, you probably disagree with some of the stats here, but it says that from the data collected, the phones have a mean of 100 hours and a standard deviation of 15, and we're asked to find the probability that the length of time a particular phone works is greater than 127 hours. So with all these questions, there are two different approaches we can use. The first one is using our GDC, and the second one is using the tables which are provided in the exam. If you use the GDC, that's fine, but just remember that if you don't show any working and you don't get the answer wrong, you will come away with no marks, whereas if you use the tables, your working may well get you some marks as well. The GDC method is by far and away the simplest. So just to show you first of all with the GDC method. So what I would do here is just sketch it. No matter which approach I use, I would always sketch it. So we do a quick sketch here. It's only a rough sketch. This is the mean 100. We want to find 100 greater than 127. So roughly somewhere around here. Going to go to distributions on the calculator, look for normal CDF, which is the cumulative distribution function, because we're looking at the cumulative distribution between two different points. And then we're going to specify those points. So the lower boundary, if we want it greater than 127, the lower boundary is 127. The upper boundary, just remember that in theory this is an asymptotic to the x-axis, so this goes on to infinity. So we just need to here substitute in a really large positive number. So on your calculator 1, e to the 9. The mean is 0 from the question, the standard deviation is 15. If you just put that straight in your calculator, you're going to get the probability that L is greater than 127, which is equal to 0.0359, so about 3.6%. The second method that we can use is a little bit more complicated. It's using the tables and standardizing the distribution that we've got here. So at the moment we've got L is normally distributed with a mean of 100 and a standard deviation of 15. So what we need to do here is standardize it. So we're going to take our value of 127, so we're then going to subtract the mean and divide by the standard deviation. So this is what we mean by standardizing the value, which will give us this value on the standard normal distribution, and then we can use the values that have been provided for us in the table. So using this method then, we would effectively be finding the probability that Z is greater than 1.8, but the tables give us the values less than the particular value here. So in the tables, we would be given, in effect, let's just do it in a different color. In the tables, we would be given the probability that Z is less than 1.8. So the tables are going to give us this region here. So if we use the tables, we can find that the probability that Z is less than 1.8 is 0.9641. But obviously we don't want this blue area here. We're interested in this area. Fortunately, we know the total area under the curve must equal 1. So if we do 1 minus this blue area here, we will also be left with this region here, and we should be able to see that that will also yield an answer of 0.0359. For part B, again, two different ways that you can approach this, and I'll start again by going through the GDC approach because it is the most straightforward. So in part B then, we are trying to find the value of D such that the probability that the random variable L is less than D is 10%. So unlike in the first question where we were given a value and trying to find a probability, in this part we've been given the probability and we're trying to find a particular value. So we're going the other way around with the inverse. So this approach is essentially going to be using the inverse normal distribution function on the calculator. So we're going to distributions and then inverse normal. We're trying to find the probability that we're trying to find the value of D such that the probability that the random variable L is less than D is 10%. So again, always start by a sketch. So roughly we've got something like this. 10% of the data, or there's a 10% chance that the data has a value lower than D. So just sketch it by marking D on here. On the inverse normal distribution function on the calculator, we need to put in the area. The area is the area to the left of D. Now, in this instance, we've been given the area to the left of D. We know that's 10%, so put in 10% there. The mean is 100 hours, and standard deviation is 15. Just substitute that in, and you will end up with the value of D of 80.776. And then if you just have a common sense check, if the mean's there, that looks broadly like it's feasible. The alternative approach then is to use the tables. If we use the tables then, the tables are based on the standard normal distribution. So the first thing we do is transform our distribution, which is here, onto the normal distribution. So whatever our value D is, we're going to need to subtract 100 and divide by 15, which is the standard deviation. And in effect, what we're trying to find then is the probability that the value such that the probability that Z is less than D minus 100 over 15 is equal to 10%. Now, however, if you look down the probability column on the tables, you will see that the probabilities only start at 0.5. So we're going to have to somehow manipulate it. So via symmetry, we can see that there'll be an equivalent point over here. And we know that the area to the right here must also be 10%. So what we could try and figure out is the value on this side such that D minus 100 over 15 was less than 90%. However, again, if you look at the tables, you won't find a probability of 0.90. So you've actually got to try and crack this particular problem using the percentage points table, which is the second table. And you can find that the probability, if the probability to the right of this value is 0.1 or 10%, the corresponding value for the standard normal distribution here, this would be equal to 1.2816. So from the tables, we can establish that the probability that Z is greater than this value is 10%. If we look at 10% in the table, we'll find the corresponding Z value is 1.286. Via symmetry, if this point here is 1.286 because the mean is 0, this value here must also be equal to negative 1.2816. So now we've got an equation where we can set this value, D minus 100 over 15, equal to negative 1.2816. And that is also going to yield an answer for D of 80.776 as well. This approach is more convoluted, but you can pick up method marks for this. If you go the calculator method and you don't get the answer correct, you won't pick up the marks for your method working. Part C is arguably one of the toughest parts in this paper because it is cunningly disguised. We are told in the question, Alice is about to go on a 6-hour journey, and here we are told, given that it is 127 hours since Alice last charged her phone. Now, when we see given that, we should be thinking that this is a clue that we are looking at conditional probability, which is actually very easy to miss. But that's what the given that is suggesting. So given that's 127 hours since Alice charged her phone, find the probability that her phone will not need charging before her journey is completed. So let's try and figure out what it is we're actually working out here. So essentially, we are trying to find the probability that L is greater than 127 plus 6 is going to give you 133 hours because we don't want it to run out before the end of her journey. But since we've been given this additional information here, we are using the conditional probability. So we're trying to find the probability that L is greater than 133, given that it is 127 hours since Alice last charged her phone. So essentially, we're working out the probability that L is greater than 133, given that it has already lasted 127 hours. So again, here the easiest way of working this out is to use the calculator function. So first of all, then, if we look at the probability that L is greater than 133, we're looking at L, which is normally distributed with a mean of 100 and a standard deviation of 15. So in this instance, we are going to use normal CDF, and we are going to use a lower value of 133 because we want it to be greater than 133, so that will be the lowest possible value. The upper value, again, will just be a really large positive number. The mean is 100 and the standard deviation is 15. We're then also using normal CDF going to try and find the probability that L is greater than 127. So again, here the lower bound will be 127. The upper bound will again be a really large positive number. Mean is 100 and the standard deviation is 15. So from our calculator, we should end up with a value for the probability that L is greater than 133 of 0.0139, and the probability that L is greater than 127 is 0.0359. So in order to find the conditional probability that the phone does not run out on her journey, given it's already lasted 127 hours, we're just going to divide those. So that is going to be 0.0139 divided by 0.0359, which is going to give you your final probability of 39%. So going through the same question then using the tables. So we've said that we're trying to find the probability that L is greater than 133 given that L is greater than 127. So again, if we want to use the tables, we are going to have to standardize our values. So this is essentially what we need to work out. So we are going to have to standardize these values. So the probability that L is greater than 133, if we standardize that, that will be the same as the probability that Z is greater than 133 minus 100 over 15 divided by the probability that Z is greater than 127 minus 100 over 15. So if we do that, if we standardize that, then we are going to end up with the probability that Z is greater than 2.2 divided by the probability that Z is greater than 1.8. So again here, one of the problems with this is the values given in the table are not exactly what we want. So if we just take this example here, so here's our normal distribution. We're trying to find the probability that Z is greater than 2.2. So we want to find this area here. However, if you were to look up the Z value of 2.2 in the tables, the corresponding probability is actually would be this area here. So when we look it up in the tables, essentially what we're going to need to do is 1 minus the probability that Z is less than 2.2 divided by the probability divided by 1 minus the probability that Z is less than 1.8. So we end up with that method 0.0139 divided by 0.0359, which you'll note is exactly the same thing that we would have got using the calculator, which therefore unsurprisingly yields the same answer of 0.39 or 39%.